Axle oils need to do their job in many extreme conditions. When the weather turns colder, the viscosity of oil tends to increase, and it doesn't flow as easily. At extremely low temperatures, the oil barely flows at all, reducing its ability to lubricate and protect the axle components. Those sluggish starts on cold days are due in part to the higher viscosity of the cold lubricant in the axle and transmission. It's important to select the correct SAE viscosity grade for your climate or conditions, using lower viscosity oils for cold climates and higher viscosity oils in warmer climates, or simply using a wide-span multi-grade oil. Automotive gear lubricant viscosities are defined in the SAE J306 standard. It defines the relationship between viscosity grade and the oil's viscosity at specific temperatures. Based on J306, you know that an SAE 75W grade oil can be used down to minus 40 degrees centigrade. An SAE 80W can be used to minus 26 degrees, and an SAE 85W oil to minus 12 degrees. But how do we actually test an axle oil to see if it has the correct flow characteristics for use at low temperatures? Well, we rely on a test rig using a Dana axle that's filled with test oil and then cooled to the test temperature. The axle is prepared by fitting it with perspex covers and temperature sensors, and then coupling it to an electric motor. The axle is then cooled to minus 40 degrees centigrade. In the bottom images, you can see the ring gear through the perspex cover. The top images show the inspection window where you'll be able to see oil flow to the pinion bearing. The oil being tested on the left is an SAE 80W90 oil, and on the right, an SAE 75W90 wide-span multi-grade oil. The electric motor connected to the axle tries to turn it. At minus 40 degrees centigrade, the 80W90 oil is too viscous. The axle can't be turned, and the motor stalls. The axle containing the 75W90 begins to turn immediately, and oil starts to flow over the gears. The partial flow of oil to the pinion bearing can be seen in the inspection window and occurs after 18 seconds of operation. In this test, if the axle can't turn, the temperature is raised incrementally until the axle is able to turn freely. The axle containing the 80W90 is incrementally warmed, but the electric motor driving the axle continues to stall. This test shows the oil in a real-life application, visually demonstrating the benefits of using the correct viscosity grade oil for a particular operating environment. It's not until the 80W90 oil has warmed to minus 28 degrees centigrade that it starts to turn freely. Yet while the axle is turning, the oil still really isn't flowing. Instead, there's channeling, where the rotating gear cuts a groove through the oil, but the oil isn't fluid enough to flow back and fill the groove. The gears aren't being fully lubricated. 40 seconds later, there's partial oil flow visible in the inspection window. Up until that point, the gears and bearings were only partially lubricated and therefore unprotected. The frost begins to melt away from the axle case around the inspection glass as it warms. After nearly 6 minutes, the 75W90 is now at 2 degrees, and there's full oil flow, giving complete lubrication and protection of the gears. From its first free rotation at minus 28 degrees, the 80W90 operated for over 6 minutes before it warmed sufficiently to achieve full lubricant flow. Watching this test, the effects of cold temperatures on axle oil are easy to see. Without the right oil, gears are starved for lubrication for several minutes of operation, which can lead to excessive wear or damage to the axle. The best solution in most vehicles is a wide-span multi-grade oil that's able to provide the needed lubrication over a broad range of temperatures, from summer heat to winter cold.